if anybody doesn't know me, as they should do, first of all, thank you for coming today. We do appreciate, we try to put on a good show, and we do appreciate people coming. My name's John Bottomley. I've been riding motorbikes for 70 years and still learning. And I've been in Brooklands about 20 years, and we've been behind a lot of the events that we've put on, etc. And one of the things that we want to try and do here is not just display old bikes and historic bikes and whatever, but try to recreate the atmosphere, because Brooklands was famous for its atmosphere, for its innovation, etc. And what I'm going to talk about in some ways is about innovation, etc. But the first thing I want to do is to thank the gentleman sat here, Michael Braid, with the yellow. We put him in yellow so I could see him, for bringing the Ducati. And I'd appreciate if you could express in your usual way our thanks. I've known Michael for quite a while. He helped us out in the early days, and actually he enjoys it more than I do, I think, coming here and being around people, etc. What I want to do in the talk is to identify the Ducati history and explain a little bit as to why we've got two Ducatis out there. There's no truth in the rumour that if you'd bought one 40 years ago, it would incubate and come out and be like the one on its other side. Sorry, it's the Yorkshire humour, you've got to get up with that. Now then, just let me see where we go here. So again, what I'm going to try and do is to bring out the heritage of what we're doing here. Right, so we've got the 2003 GP3 Desmosedici racer, ridden by Loris Capirossi. I want to tell the story of the World Championship, which I think is important to fit this bike into. I want to tell the Ducati story as well, briefly, and the bikes that they developed. I'm not an expert on Ducati. I'm sure there's more people in here who know more about Ducati than I do. But what I've done is trying to pick up the history of what they did. So this is their D16, meaning Desmo 16 valve MotoGP V4. So if we move on here. So we go back in the World Championship. Once people made motorbikes, they wanted to race them. And we have a 1903 motorbike in here, which was not a racing bike, but it was developed. I rode it in the London to Brighton. But I bring that out because that was probably one of the earlier engines to go into a motorbike, and it was very advanced design at the time. But I'm going to talk really about the World Championship from the end of, which started in 1949. Prior to that, there used to be championships in 500, 350, 250, etc. And then in 49, a famous guy, Les Graham, rode the AGS Porcupine, which probably not many people have heard of. It was an AGS developed after the war. It took into account a lot of the technology that had been developed during the war in engine development. Because when you look back on it, in 1900, somebody figured out that you got this thing called petrol, which incidentally doesn't burn. People think it does. But petrol actually vaporizes, mixes with oxygen, and goes bang. And I've just been reading a 1906 book, and they described that process as vaporizing oil, mingling with oxygen, and then if they get a good mixture, it bonds with oxygen. So this is the words. The words are not there. And now you've got to a point after the war where there was quite a lot of stuff understood about engines and how they worked, etc. So Les Graham won the 1949 World Championship, and I've got two numbers up there. I'm trying to give a presentation to people who don't know anything about motorbikes, and I'll have all the aficionados out there who know more than me do. but I've got two numbers, the 60 brake horsepower. Now that is measured on a machine. Some people call it a rolling road, but it's the amount of energy needed to accelerate an object. And the other one is BMEP, which is brake mean effective pressure, which is a measure of the pressure in the cylinder. Now, the 1903 bike that we've got downstairs had a brake horsepower of probably about 2 and a BMEP of probably about 10 or 15. So, you know, we come after the war and we've got this bike here, which was phenomenal at the time. The Manx Nortons were producing probably 50, 45, 50 brake horse. This was more, the V-twin, and you've got 108 psi. So that championship ran until 2021, and the FIM changed the rules in 2020. Oh, just a minute. That's right. And introduced MotoGP as a new concept, and introduced the 1,000 brake horsepower, 1,000 cc formula. And I put those numbers up there because at the back end of that period, the two-strokes started to come into their own, and people realised the power that could be developed in a two-stroke engine. And if you look at those numbers there, 187 bhp and a BMEP of 203, so you can see the improvement in efficiency. Now, the 203 figure actually matches with Formula One. This is about as far as you can get to. And that was achieved with a two-stroke with no valves, and it was simply by filling the cylinder. So just for those that think that, so in other words, once up and down, you get one bang. With a four-stroke, you've got to go up and down 4 times to get one bang. So this presented a real challenge, because if you wanted to run a four-stroke and produce in excess of 100 and odd brake horsepower, you needed to figure out how you could do that. Well, you can do that by revving the thing at higher revs, so that you can do the numbers there. You know, if you do 20,000 RPM, you can get your 2 bangs with the same amount of power output. Okay? Does that make sense? The other interesting figure out of this is that the brake horsepower per ton of that Honda is about 1,800 horsepower per ton. It's only got 2 wheels. Formula One at present is about 12 to 1,300 bhp per ton. It's got 4 wheels. So you understand the sheer challenge of riding some of these bikes. They were absolutely unbelievable to ride. Okay? Right. At the other point about about the championship is that Norton were quite successful in the early 50s, etc. Not because they had powerful engines, but because people could ride them. The handling. You'll have heard of the road holder, the frame, etc. And that was their real benefit. And if anybody goes back far enough, Jeff Duke went from Norton to Gilera, and he was taken on by Gilera to make the handling of the Gilera better. It had a much more powerful engine, but the handling was a big issue. So in 2002, heavily influenced by the Japanese, because the Japanese wanted to sell motorbikes, and selling rip-roaring two-strokes didn't sell motorbikes. So they influenced the formula to produce what is currently the MotoGP. 994-stroke was allowed, and they put a weight limit into it of 154 stroke 7 kilograms. It depends on whether you had a two-stroke, but that number is somewhere about 155 kilograms. They took it down to 800 cc in 2007, and then now in 2012 they went back to 1,000 cc, etc. So that gives you an idea of the championship. So if we then move on to Ducati. Ducati, again, it's my take on this, had a small motorcycle group. They were, like the Italians, were really into their racing, small engines, small racing bikes, etc. and some very creative designers and engineers. So the milestones to the MotoGP bike that you see there is on the left in the 50s and 60s, the four-stroke Desmo. Now, that was the reason why I've got my bike there, which is 250. It's not a Desmo, but it's actually 1 year off the Desmo. That is 1968, okay? So in those days, all the young lads around, and I was an old man by then, wanted something like that. And mine revs to 9,000 RPM, which in 1968 was about 2,000 RPM more than a Manx Norton. And the problem that they had in those days was a materials problem, which is often interesting. And they used to get wire breakages in springs, so that and the industry was used to low revving engines. So actually Ducati brought in bevel drive, overhead cam, and then moved into desmodromic valves. Now, a desmodromic valve, for those that don't know, or Desmosedici as the Italians, it sounds nicer in Italian, doesn't it really? It's basically a means whereby you open the valve with and again with a cam, goes round, and it pushes the valve up, and it goes back down again with a spring to close it. And so with the problem of these things, and certainly in the racing side, and you'll see who brought this in later, they came up with a way where you open the valve mechanically and you close it mechanically. So there's no spring. Well, there is a spring, but basically there is no spring. Okay? So that's the desmodromic. And everybody thought about Desmos. They weren't the first people to do it. A lot of other people did it, but that was part of their selling point. Buy one of these things, it'll rev to 9,000 RPM, and it won't break its valve springs. That's in simple terms. And that one of mine has been at 11 and 11,500 occasionally, because I miss a lot of gears with it, because the gear change on it is CRAP. Okay? So that gives you a very solid engine. Then in 1970, they took the bevel drive, so they took the single-cylinder engine and made a twin. Okay? And then in 1986, they came up with the liquid-cooled cog belt-driven 8-valve V-twin, which was the start of their great success in World Superbikes. And then you come to 2003, and you've got the MotoGP bike down there. So we'll go on a little bit more to that. The people behind this, and one of the interesting things about this is that, and I think this is a difference to the UK, we as a country tended to have much more practical application of design, etc., where the Italians had an academic, I'll call it an academic route to design. And they took this guy from Mondial, I think it was, Fabio Taglioni, Dr. Fabio Taglioni. He started his education before the war and finished it after the war. And his thesis was direct springless valve operation, desmodromic valves, basically. And he brought that from Mondial to Ducati. He was seen as a very forward-thinking, young guy, just the sort of guy that you want in your design shop, etc. So he was the bevel drive single, desmodromic valves to combat spring breakages, and he also did a lot of work on 2-valve hemispherical heads. And if you look carefully on mine, and you'll see it in this photograph, he did something that Norton did in the 30s. And what I was talking about earlier was mixing vapor and air together. And one of the things that Norton did, and it went through, he picked it up and he offsets the inlet valve, the inlet tract from the inline, okay, and inclined it into the valve, okay, and does the same thing with the exhaust. So if you imagine a charge of this wonderful mixture of vaporized petrol and air that had got intimate and got together. You push it into the cylinder head, you set fire to it in its flame path, and it comes round and goes out the exhaust. I mean, that's a very simplistic explanation. And that was one of his design features, not original, but he put that in. And one of the things with a really good, mine isn't as good as this, you should put 2 plugs into it because you can pick up the gas flow on either side of the piston, and then when the piston gets to the top, you get squish. In other words, you squash the thing, and you get a lot of power output. I mean, 30 brake horsepower out of a 250 back in that day was pretty revolutionary. And he also came up with a 90-degree V-twin. Why 90 degree? Well, 90 degree gets over a problem of vibration. Okay? Bear in mind that people have got to ride these things. And one of the things with a lot of British bikes, they tend to suffer a lot from vibration. And if you're going like this all the time, 2 things happen. The rider isn't particularly able after a long race to continue. And secondly, things break. You wear them out. So the 90 degree on primary balance, a 90 degree V-twin is vibrationless. And a famous guy, Phil Irvin, who designed the Vincents, reckoned that a Vincent engine was never a good racing bike. But the other benefit of a 90 degree V-twin, and if you look at this photograph here, you can lay one cylinder down and the second cylinder is in the airstream. So you get good cooling of the back cylinder. Whereas in a 45 or 60 or whatever V-twin, all the cooling comes into the first cylinder, air gets hot and warms the back cylinder up, you don't get the cooling. So when you get to real performance, that's another benefit of the V-twin. Now, if we then go on, the second man that played a big part in Ducati's story is Massimo Bordi. Now, Taglioni took him on as a young lad, if you like, or from university, again with an academic background. And his thesis was on Desmo Quattro cylinder head design. So in other words, Desmodromic 4-valve cylinder head. And what I talked about earlier was a hemispherical chamber where you put 2 valves in, and it's always been a problem of what angle you can get them at and blah, 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 blah. However, and it goes back to Rudge, whenever Rudge did this, somebody had the bright idea, we put 4 valves in. And when you put 4 valves in, you can get bigger area to get more of this wonderful mixture into the cylinder head. And you can also, and this is really important, you can put the plug, the firing point, in different places, because the middle bit where you really want it is not taken over by the valves. Does that sort of make some sense there? Now, this engine, and I'll come on to the politics in a minute, this engine with a 16-valve V-twin was the basis of Ducati's success in World Superbikes. And there's the numbers there. I didn't realize this until I saw them. Those numbers are a bit out of date, but when you look at it, they had 14 titles. And Honda only had 6. And Honda is a huge organization compared with Ducati, because Ducati went from a small organization and tried to get into this. And you'll notice with that V-twin as well, they took away the bevel drive. And that really was a marketing initiative, because the bevel drives are too expensive to manufacture. They've got to be set up in the factory, taking time, etc. Whereas if you go to a belt or a chain drive, then you get a simpler, same effect, still does the same job, etc. thing. So, having been recruited by Bordi, he also understood one other thing, that if you wanted to produce a lot of power out of an engine, you had to do what Scott did in 1920 and water cool the engine. So you had a situation, apparently, if what I've read is correct, in the factory where you've got Taglioni, who was like the real man. He didn't believe that 4-valve heads were necessary. So the management commissioned body to produce a demonstration engine. And it was all done outside, put together. He designed it. It was all put together. And the management sent Taglioni to Russia on a month's business trip, right? So you can imagine. And when he came back, they'd set this tests up and that. And this engine was, just a minute, this engine, sorry, I'll go back, was the first mock-up to produce more than 100 bhp from a twin engine. The other thing that Ducati had done over the years, still keeping the Desmo, and they kept the Desmo even though they could have gone to conventional valve springs because of a marketing thing. If you talk to anybody, Desmo, Ducati. If you talk about V-twins, 90-degree V-twins, Ducati. And a lot of people don't know why it's so good, but that's what they kept, because they introduced it to try and get into the American market, because obviously you've got these bloody great things called Harley Davidsons and Indians and whatever, V-twins, but not very efficient ones. So they got into that as a thing. Okay? Now, so they've got all this experience of some racing, because they did produce some racing bikes, etc. But they were all street bikes in inverted commas. It was world superbikes, etc. And so you've got this new formula in 2003. And they had all this experience available to try and build a bike, because MotoGP bikes are specifically designed for racing. They're not sold to the public. They are designed for racing. So they had this remit, if you like, and they decided that they would make all the power they could engineer out of a V-twin with desmodromic valves and figure out how to make it rideable. So the first thing they realized, as I said earlier, we've got to make these things rev to 20,000 RPM, which was their original intention. And that had not been something that people did with four-stroke engines, really. And then they had, and I understand that they had like I was going to say a spreadsheet of, if you do this, then that's the result. So you can have this and that. And so they had all this information. And even at this date, they were still a relatively small company, beginning to get bigger. I mean, now they're owned by Audi, and they are top whack, and they've cleared off the Japanese out of the MotoGP. But this is sort of a transition. So they wanted to keep the 90-degree V-twin. They wanted to reach the Desmosedici, and high-revving engines were necessary to combat the 185 bhp produced by the two-strokes, because if they weren't quicker than that, then they'd give up and go home. So outline design, and they thought about keeping the V-twin, and I put the numbers up there. So can you imagine making 112, so that's 4 and a bit inch piston moving up and down 2 inches? Formula One does that, the ratio, not necessarily the size of the piston. And they thought that was no good. That was just not going to happen. So they had to go to a V-twin, V4 rather, to get over that. So if we come round here, 90 degree, now I don't know, Michael probably knows better than this, the numbers and that, but some of these I've guessed from what I've read. They don't. One of the things about these bikes, they don't like people to know what they're doing and why they're doing it, etc. So the 86 by 42.5 is what I guess the engine is. So again, you run in a factor of 2 with a ratio of 2 of bore to stroke. Mine is 74 by 54, I think, the 68 one. So again, quite over square. For those that don't know, over square means it's bigger that way than going up and down. So that's the thing there. 4 valves per cylinder, and the first year they came out with it running at 16,500 RPM, which I understand was about 1,000 RPM more than Honda were capable with their inline 4s. And this sent shockwaves to Japan, because this thing was a real powerful beast, really was, compared with what thing. And the injection and ignition, I think, is back to Ferrari. There's a link there back into Ferrari. Because these are early days, this is where you're just beginning to come into electronics and control systems and whatever. This thing was, how the hell some of them rode it. It really was. So just looking inside it a little bit, it might be interested, that you've got the camshaft. That flat there is the closing aspect of the, so that's what they close it with. There's not great photographs of my face, but the only ones I could fiddle and pinch. And that's your cam. So that's your opening and closing cam, and you see all the way down there. Now, why did they keep that? Well, they were faced with a problem. Everybody else used hydraulic or pneumatic valve operation. They knew nothing about that as a company, apparently, but they knew everything about this, and it works. I don't know anybody, if there's any Ducati people come and tell me, no, it doesn't. It does work, and they've ironed out, or they thought they had, all the problems with it, and said, right, we keep that, it's a marketing thing, and it works, so they don't have to spend time and money on that. And you get an idea there of what it, I think it's wonderful, it's not a very great photograph to see, but I mean, imagine what that lot's doing at 20,000 or 16,500 RPM. It's just mind-boggling to see what you're with. And you'll see some of the numbers later on. The big problem they have, and again, they've solved this, you've got to be very, very accurately machined, because all the valve clearances and everything are in that setup. You don't have shims and adjustments and everything. Maybe they have, but basically, they've got to be high-quality manufacturing. Some of the features of the engine, they started off on high temperature cooling to try and get the size of the radiators down, because if you're going to push this thing over the air at 200 miles an hour, the smaller you can make it, the better. They also tried what they called the twin pulse and the 4-pulse. So in other words, they've got a 360-degree crank and a 180-degree crank. So a 180-degree crank does that, the 360 does that. So you get a bang for everything together. And I think Michael said to me, the riders preferred the 180, because when you got the full bang, it was pretty big bang. I also think that what they did, because they were getting breakages at the bottom end, what they did was move the one cylinder by about 60 or 70 degrees. So you've got your 90-degree one cylinder, and so you ended up in a situation where you got the first bang, and they delayed the second one by 60 degrees, so that you're smoothing out the power delivery, because this has to be ridden by somebody. This is the real challenge. So that's one thing. The titanium conrods, very expensive, 98, and the ratio of 2.3 to 1. So in other words, you've got a ratio of the length of the conrod to the stroke. So that gives you some idea what you're up. The pistons, which again, Michael's seen these, but British company, a bit of success here. Omega worked with them, and I don't know whether it's on here. The piston, the acceleration on the piston is something like 9,000 G. It's just reflect on that. You read things about people in aircraft doing, what, 5 or Formula 1 cars, doing 5, 8, 9, 10 G on their neck. Can you just imagine what 9,000 G to a piston must be like? It really wakes them up a bit. And in fact, some of them are even up to 10,000 G. They give you an idea of the stresses that are actually in the engine. So what they've done with the pistons was to make them like a honeycomb. So they take away the top, the head of the piston, which normally would be reasonably thick for heat transfer. And actually what they do, when we first started this morning, you've got to run it without starting it to get the oil circulation in it. And it pushes oil under the base of the piston to keep the heat out. You know, the thing is full of ways in which they lubricate things. It's gone are the days where you've got a sump and stuff going round. It's like the gearbox, which is a vertical gearbox. The shafts are vertical, and there's no oil particularly in the gearbox. All the gears are squirted oil to stop, so it reduces the friction and everything in the gearbox. You just get the lubrication that comes out of that. You look at the valve stems. Again, you've got the lifting, 12, 13 millimeter lift on the valves, on a 39 millimeter, 5 millimeter diameter. If you can visualize, you know, these things are very thin stalk with a damn great big head on them. Now, one of the things I learned, and I'll pass this on to people, anybody around, and I'm a few in here, one of the things about getting power out of an engine is what they call valve overlap, okay? So unlike what you would think back in the day, they used to think if you've got a piston going up, you close the valves, put it to the top, set fire to it, and it comes down again. Yeah, it does that sort of thing. But you can actually get better performance by having the inlet valve and the exhaust valve open together, because you've got stuff coming in, stuff going out, different waves, and you put more of this wonderful mixture into it. Now, I've always thought that the more overlap you can get, the better it is. Reading up on some of this, what it does actually, it gets rid of mid-range power. So the wide overlaps take away mid-range power. So how do you get over that? Well, what Ducati have done, and other people now do, is you reduce the valve overlap, but you make a bigger lift. So you've got an envelope where you're letting more in for a shorter time, but it's the same as if you have it open. Does that make sense? Yeah. And that does away with the valve with the loss of power. And these are the sorts of little things that Ducati and many other people have come up with. So you end up with, and I put 200, 250 bhp. I think, to be perfectly honest, they're academic numbers. You get the numbers that they want. The other thing which is interesting to me, and I think a lot of other people, is that everybody who rides a bike rides it differently. One thing I don't know whether you know, but everybody has got a different gait. If I walk across here, this is a unique gait. Every one of you has got a unique gait. It's a bit like a fingerprint. If you ride a motorbike, you will ride a motorbike differently. And when you look at present, I mean, yesterday at the sprint race at the Saxon Ring, the first 4 people were in less than a second after 15 laps. And they were all on Ducatis. Well, not all of them. but equally, the thing that you see now in modern GP, they've got plenty of power. The problem is trying to maximize the power over a period of a race so the guy can ride it to the limit. You know, you hear a lot about the late breakers, but there are other people can carry higher corner speed because in here, in their physical makeup, they're good at different pieces. And these bikes are actually set up for the rider. You know, and they've got the ability to do that. Now then, the other one which I learned recently, all the modern GP bikes have got GPS on them. Right? GPS. As somebody said, you could say, well, it's just so the guy gets around the corners and knows where he's going, you know, sort of like. No. They introduced into the formula 22 litres of fuel. And what they're doing, I mean, this just gets to me to be mind-blowing. They are controlling the fuel injection into the bike depending on where it is in the track. So in simplistic terms, if it's going up a hill, it's shoving fuel in. If it's coming down a hill, I'm making simplistic now, that for that period that it's maybe not at full stretch or braking when it's shut off, they're cutting off the fuel so that they can maximize the fuel and power output into the place where they want it. With this bike, and we'll come on to the last slide, what it did for them, first time that they went into MotoGP, 1 win and 8 podium finishes. Harnessing the considerable power was a challenge. I think that's an understatement. And Capirossi and Bayliss were second in the Constructors' Championship, and they did have reliability problems with it. And I think that is, is an incredible achievement for a company that had never actually made a really pucker MotoGP bike to a new formula, and it scared the daylights out of them. Now, they believed with this that they were having a problem with wheel spin. So in 2004, they diagnosed that problem as putting the engine in the wrong place. So for 2004, they moved the engine back. Well, it didn't solve the wheel spin problem, but it made the bike totally unrideable because there was no weight on the front. I mean, I'm exaggerating now, but they took the weight off the front end and nobody could really ride it. So they wasted a whole year and finally realized the problem wasn't where the engine was, it was the delivery of the power that was the big issue. They recruited Stoner. Now, again, we're getting into the era where they're going into chips. Not fish and chips, sorry. Controlling the thing. And so what they can do, and I think Stoner was a bit of a revelation in the MotoGP world because he came from a background of motocross. He had a very strong off-road motocross capability. And if I'm right, I think I'm right with this, that Rossi was scared stiff that, because Rossi was in his heyday, and here's this Australian comes who used to ride off-road. Rossi put a motocross track in and practices, and you'll find now most of the MotoGP guys ride motocross to get themselves there. So the other thing with Stoner, he would ride that bike differently to anybody else, and nobody at the time could match him. And it's only this year that Pecco Bagnaia has actually more Ducati wins than Stoner have back in the day. Now, one of the ways that I understand they controlled the power output, they had 3 means of controlling the power output. One, I'll get this right if I remember it now. One was to retard the engine, okay? So they would have a mapping for it that would retard the engine, reduce the power output. They also developed in the chip arrangement, if you look at the power output of power and torque, they actually matched the two to be beneficial. Let me make a simple example. The torque's going to spin the back wheel. The power's going to push it through the air, that in simplistic terms. So what they did, they produced on the throttle what they called a power band. So this thing would be delivering the right amount of torque and power for a given throttle opening. And then the final thing that they put into the mix was to cut the cylinder off, shut it down, so it didn't fire. So they reduced the total power output. And Stoner was able, and when you read about it, nobody really knew. Stoner seemed to have some mix of variables that he could ride it with, that nobody else could manage with. And that's why he was so successful. And then Rossi started pushing him, and the rest is sort of history. Okay? Now, that is a brief you know, there's many other things I could talk about. I don't know whether my voice would last much longer. Have I got everything, boss? Was it all right?
One thing you didn't mention, John, was the problem they had at the beginning was heat.
Oh, yes, yes, yeah.
The bike basically was generating a lot of heat, and they had to cut holes in the fairing.
Yes, yeah.
To the extent of having to drill holes to stop the riders getting burnt.
Yes.
Their hands
Yeah.
were getting toasted.
Yep. It's good to have a mentor, you see, but he's absolutely right. And there are photographs of inch holes around the number plate at the front, aren't there? Yeah. Because the design brief was to put small radiators in so that you weren't increasing the frontal area. And I think they went to glycol or something like that, so a high energy transfer medium, which they thought would get rid of the heat in the small radiator, but they boiled the driver.
The other thing, which is quite obvious, but not many people notice it, but that bike doesn't run a front mudguard. And the reason is that the mudguard was deflecting air away from the radiators, so they said, okay, run it without mudguard.
Yeah, yeah.
Simple as that.
Yeah. Do you understand that about the heat? You hear that? That's one thing I missed out the presentation. It's good to have somebody who knows what he's talking about, you know.
You hope.
But that, and it's the same problem today. They have this problem with following people that the front tyre of the following bike gets so heated up from the guy in front. And I think it was last week that they, what was it? It was Marquez had to drop back and let somebody past him because the heat generated was putting the temperature of the front tyre up. And of course, these things, they are on the limit of the tyre and the adhesion on it, you know. Anyway, I'll be happy to talk generally. I'm not going to take questions because I can't hear because I've got my hearing aids in. But if anybody wants to chat, I'm very happy. I hope you've enjoyed it. Please tell your mates to come next time. We're trying to add value. We're not just starting bikes for the sake of it, trying to give people an understanding of how wonderful these things are, because they are a truly amazing piece of engineering, aren't they? Really. Thank you.